best fit as an exponential model is shown below. The exponential regression was calculated and plotted along with the data points. The R-squared value, or the correlation coefficient, suggests there's a very strong correlation. There's a 0.95 on this one. Watch the instructional video for details on how to do this. Okay, so let me get the calculator. And I still have the data from the last video entered in there. So doing the calculation will be pretty easy for the exponential model. So I'm going to go stat, and then calc, and then the exponential regression is down below. Okay, it's option 0 here. So enter. Then I'm going to go down to calculate. Okay, and there you can see it's y equals ab to the x is the exponential model. Important to note here, there is no shift. There's no option for a plus and then a constant term. And so this calculator has a limited ability to calculate those exponential regressions. An important note here, if you were to have the data point 0, 0, the calculator would not be able to return a function because 0 to the 0 power is undefined. So if you have a 0, 0 data point, the calculator can't do an exponential model. But in this case, we're all set. So let's take a look. We have 16.049, and we have 0.86 for the base of our exponent. So I'm going to enter that in the function. I'm going to use 16.05 and 0.86. Clear out the other one. 16.05 times, and I'll do open parentheses, probably don't need to, but I will anyway, 0.86, and then to the x power. And I still have the stat plot turned on from the previous problem. Let's graph and take a look. Okay, yeah, so that fits pretty nice. It could probably fit a little better if there was an option for a constant term in the curve fitting here. I just have a feeling, you notice these first 2 points, the curve doesn't fit very well, so I think there's some issue with that. But overall, this seems like a really good model. So once again, in order to create this model, you go to Stat, and then Calc, and then we scroll down to option 0, which was the exponential regression. And that's how we found the values for the initial amount, which was 16.05 in this case, and the growth factor, which was 0.86, and technically that's a decay factor because you have a value less than 1. Okay, so it's up to you to decide which model you think is the best, and you need to think of the context of the problem and also how close the curve or line fits the data.